Good morning. Hello, all of you. I hope you are doing well at home. Today, we are going to resume the explanation of lesson 1, chapter 3, which is what are electromagnetic waves. Before starting the lesson, we should know that we are going to revise the last two sessions because some of you are not able to join the meeting. But today, we are going to cover all the lesson. Don't forget that we are going to send you the homework. It was uploaded through person. You can solve it and upload it. It's multiple choice, and the answers will be sent to me directly. Okay. What we are going to learn in this lesson? Number one, we are going to recognize the concept of electromagnetic waves. Number two, determine what does electromagnetic wave consist of. Number three, explain electromagnetic radiation. Number four, we are going to make a comparison between polarized light and unpolarized light, and also understand what is meant by polarized light and unpolarized light. Number five, explain photoelectric effect and how can it happen, and how can we explain this phenomenon. We should ask ourselves a questions. Do we use electromagnetic waves now? The answer is yes. The cell phone that you are using, the lights that enable you to see, and every device that is connected now to the Wi-Fi is using electromagnetic waves. So, to understand the electromagnetic wave, we should answer these questions. How are electromagnetic waves different from mechanical wave? Electromagnetic wave does not need a medium to travel. Electromagnetic waves travel with high speed. All electromagnetic waves is at transverse waves, while mechanical waves need a medium to travel. They have a limited speed, and they can maybe a longitudinal or transverse. Electromagnetic waves are produced when an electric charge vibrates or accelerates. So we have an electric charge, such as an electron. When this electron vibrates, it will produce a field. So the electromagnetic waves is made up of two fields, magnetic field and electric field. The electromagnetic wave is a transverse wave. Electromagnetic waves can travel through vacuum or empty space, as well as through matter. Electromagnetic waves are transverse wave, yes, because it consists of a changing electric field and a changing magnetic field. These two fields are moved together. Between them you can find a right angle, which is 90 degrees. They are perpendicular to each other. Electromagnetic waves differ from mechanical wave in how they are produced. As we said, the mechanical wave producing from vibrating of objects, while electromagnetic waves is produced from the vibrating of electric charge. How they produce it? Electromagnetic waves are produced by constantly changing electric fields and magnetic fields. As we said, it's a transverse wave and it's made of two fields. One is electric and the other is magnetic. When these two fields are moving, they're going to change the position and they always being perpendicular to each other. So they move together. So it's a transverse wave and they made up of two fields, electric field and magnetic field. In this figure, we can see this one is the magnetic field, and the red one represents the electric field. We can see they are moving now, and they are changing the position with each other. This line represents the line of propagation, the direction. We can see both. This represents the plane of the electric field. It's perpendicular or making a right angle with the direction. Also, the magnetic field make a perpendicular angle with the direction. So both are making a perpendicular. Both are moving perpendicularly to the line of propagation. How they travel? When electric field is produced, they change the magnetic field. And the changing magnetic field can cause a changing of electric field. They produce a change. So the fields regenerate each other. Electromagnetic waves do not need a medium. The transfers of energy by electromagnetic waves traveling through matter or across space is called electromagnetic radiation. So what is electromagnetic radiation? Electromagnetic radiation carry two types of energies, electric energy and magnetic energy. So when the electromagnetic wave is moved, we give it a name as electromagnetic radiation. And the electromagnetic radiation carry two types of energies, which are electric energy and magnetic energy. If they are going to move, what is their speed? Or what is the maximum speed? They are going to move with the speed of light. So what is the maximum speed of light? The maximum speed of light in vacuum is about 300,000 kilometers per second. Wow, it's a very high speed. So some scientists conduct some experiment to know what is the speed of light, and they give us an example. If the sun is away from us by 15 billion kilometers, so what is the time that the light will take to reach us? It will take around 8 minutes and 20 seconds. If we said light is a kind of electromagnetic wave, and when we studied light, we find light that has dual nature. This dual nature, so we have two models. These two models help us to explain the behavior of light or the behavior of electromagnetic wave. Wave or a particle, this is the two models. The model number one, light behave as a wave. The model number two, light behave as particle or a beam of particles. The electromagnetic radiation behaves sometimes like a wave and sometimes like a stream of particles. When they move as a wave, that represents its effect, what's happening to light when it passes through a polarized filter. This polarizing filter will allow some light to pass and prevent other part from passing. Like that. If we said this is the filter, and this filter contains slits. These slits, which are vertical, will allow only some light to pass. This light, before entering the filter, is unpolarized. But the light behind the filter becomes polarized. So the word polarized light means some of light only pass, like sunglasses. Sunglasses prevent the amount of light and allow others to pass. Because it
أستاذ
yes.
أنا أعرف هذا الإلكترومagnetic اللي قلت لي عنه اليوم واحد اسمه وش اسمه إلكترومagnetic بعدين particles بعدين هذا polarizing.
Listen, you are Abdullah. We said we have two natures or two models of light, right?
إيه.
The first one is photoelectric. The first one we give it name as
polarizing.
No, not polarizing. The first one as a wave, and this nature of as a wave explain to us. Listen, Abdullah, first explain to us this what is happening when light passing through a polarized filter. Okay, but the nature is called a wave nature. See, we have a wave nature or particle one. The wave one explains this what happening to light when it becomes polarized. And the word polarized means because light is made up of two fields that are perpendicular to each other, one of them will pass through the slits and the other will not. The horizontal will not.
إيه فهمت عشان في فتحات يعني في وش اسمه في اللايت يعني يمكن واحد منهم ما يدخل بس اللي جنب الفتحات.
Listen to me. Speak English, please. Okay. This hole is called slits, and this is very very tiny. You cannot see it by your naked eye, right? Like sunglasses. So the wave nature will explain what is happening to light when it passes through this polarized filter. And we give that two names. The light before the filter give name as unpolarized, and the light behind the filter, see, it comes like the slit itself, we give it name as polarized. While this other nature is called particle model. The particle model explains the photoelectric effect. What is photoelectric effect?
It's a tiny packet of light.
Yes, scientists discovered that light is made up of tiny packets of energy. Each one we give it name as photon.
So, photoelectric.
Yes, any material is made up of electrons, right? It contains electrons. Atoms.
It's a tiny packet. When it transfers to electron metal, it knocks it out.
Yes, when this electron get this amount of energy, it will knock out and move. This movement is called the photoelectric effect. You are right? Yes, you are right. Correct, Abdullah. So we understand the two nature of light now. See, this is a beam of light and it contains what to give it a name? Photons. Okay? When photons strike this piece of metal contains electrons. This electron absorbs this amount of energy, which is photons, and knock out. This movement or this phenomena, we give it a name as photoelectric. Okay? So, what is photoelectric effect? The emission of electrons or knocking out of electrons from a metal caused by light striking the metal is called the photoelectric effect. Okay, this is little assessment. Question number 1. How are electromagnetic waves different from all mechanical waves? Who can answer?
أنا مستر مين؟
Let's say your name first.
عبد الله.
Okay,
And I can answer it. How are electromagnetic waves different from all mechanical waves?
So the answer number?
Electromagnetic question C.
C. The answer is C. No.
D.
It's D. Electromagnetics can travel through vacuum.
Travel through a vacuum.
Yes, as we said in the beginning. Next question.
لا اصبر والله بالغلط هم بلانك.
Okay, Abdullah. Okay, Abdullah. I received your answer. Abdullah. Okay, we know the right answer now. Question number. The photoelectric effect is evidence that light behave like what? Who can answer this question?
Turkey.
Abdullah, give a chance to answer.
لا احنا اللي جوة الكود.
So his answer is B as a particle. Yes, the answer is B. You are right.
ما قال شيء.
So a photon travels farther from a light source. The intensity or the strength of light stays the same or not? True or false?
False.
False, of course. Its answer is false.
هو بيسوي decrease ولا increase?
Now, don't forget Abdullah.
ولا واحد.
Yes, don't forget Abdullah and all of you. You will find your homework on personrealize.com. You will log in using your password and username. You will find an assignment, solve it and submit it again. Thank you for all. This is the end of our session today. Thank you.